Okay. So, good morning, class. So, last week natapos na tayo sa discussion ng Carnot cycle, no? Wait lang. Pwede. Ano rito? Okay, meron pa? Ayan. Okay, so last week we were able to discuss Carnot cycle. We were able to derive the different equations, like equations to solve or formula to solve the heat added, the heat rejected, and lastly the efficiency of a Karma cycle. So for today, what we are going to do is we are going to solve three problems related to Karma cycle. Okay, so let me just share my screen. And while I'm fixing this, please review the formula because I will call someone to solve this problem. Let me know if my screen is already visible.
Kita na po.
Okay. Okay, so this is sample problem number 44. Calculate the maximum efficiency of a heat engine with operating temperatures of 500 degrees Celsius and 100 degrees Celsius. So from the formula that we have last week or 2 weeks ago, what is the formula to calculate for the efficiency of a Carnot cycle? Anyone who still remembers the formula? Miss Sada?
Yun po ba ma'am yung T1 minus T2 over T1 po?
Yes. So let us solve this problem, no? Just so let us first write the given data for this problem. So if we are going to discuss or if we are going to solve a problem related to Carnot cycle, let us denote the temperature as TH, T sub H, and T sub L. So this means that T sub H is the high temperature or the temperature coming from the hot reservoir, and then the T sub L is the temperature coming from the sink, no, or the cold reservoir. So let us write the given data. So in here, we have 500 degrees Celsius and 100 degrees Celsius. So which is our T sub H? What is our T sub H, class?
500.
Okay, this is 500 degrees Celsius and T sub L is 100 degrees Celsius. But before we proceed, class, with the computation, remember to always convert these temperatures to absolute temperature. So let us convert 500 degrees Celsius and 100 degrees Celsius to absolute temperature. So for the first one, we are going to add this by 273.15, and same with the temperature at the cold reservoir. So what is our T sub H in Kelvin?
773.50.
And what is our T sub L in Kelvin?
373.50.
Okay, and the required parameter is the efficiency. We are now going to proceed with the solution. So formula for efficiency, we can write this as T sub 1 or T sub H minus T sub C or T sub L all over T sub H. Or we can also write this as 1 minus T sub L over T sub H. No? Maalin or either of the two will do. So let us substitute the given data. For the first one, we have 773.15 Kelvin minus T sub L, which is 373.15 Kelvin, all over 773.15 Kelvin. So dito, I can write this as 373.15 Kelvin over 773.15 Kelvin. So use your calculator, class, and solve for the value of efficiency. What is the value of efficiency, Mr. Gonzalvo?
0.5173640303.
40303.
Yes.
Okay, and we are going to multiply this by 100%. So the efficiency is 51.3 decimal places 736%. And for this one, what's the answer? It should be the same. So this is 0.51736 40303 times 100%. So this is also 51.736%. Okay? Do you have questions, class? All clear? So let's now proceed to the next problem. So take a screenshot first before I proceed. Done? Okay. So next problem natin, kindly read Alan May.
Kelvin and 700 Kelvin. If 14,000 joules of heat energy is absorbed by the engine, how much heat energy is discarded into the cold reservoir, and how much mechanical work is performed by the engine? Then calculate the efficiency of the Carnot engine.
Okay, so for sample problem number 45, we are going to write first also the given data. So let me call someone to tell us the given data in the problem. Say use. What are the given data? Mr. Ginhawa, Mr. Angeles,
Ma'am, ang T-high po ay 700 Kelvin.
mm-hmm.
Tas ang T-low po ay 400 Kelvin.
Okay. What is
Tas yung
14,000?
14,000 joules po ay ang QA.
Correct. And what is or what are the required parameters in the problem?
QR po.
Letter A is QR. For letter B, this
work
is
net po,
yes, correct. And lastly,
efficiency po, yung
correct.
M.
Okay, let's now proceed with the solution. Who wants to volunteer to get for the QR? Who wants to solve for the QR? Who wants to try? Okay, so before we solve for QR, let me teach you one of the concept in a Carnot cycle. So in a Carnot cycle class, remember that the ratio of the high temperature and low temperature, or let's put it this way, the ratio of the low temperature or the temperature coming from the cold reservoir to the temperature coming from the hot reservoir is equal to the ratio of the heat rejected absolute value over the absolute value of the heat added. So remember this class. Again, the ratio of the temperature coming from the cold reservoir to the temperature coming from the hot reservoir is equal to the ratio of the heat being rejected from the system to the heat being added to the system. Are we clear on that? Did everyone get that? Okay. So for letter A, given that we have this relationship, who wants to solve? Who wants to try to solve for QR? Just raise your hand. We have TL, we have TH, we have QA. Mr. Saki, what will be the formula for letter A?
Ang formula po ay TL over TH is equals to absolute value of QR over QA po.
Mm-hmm. And how will we get for QR?
Yung formula po para i-derive po natin.
Mm-hmm.
QR is equals to TL
Mm-hmm.
times absolute value of QA over TH po.
Correct. And let us substitute. So what is TL class? Mr. Saki.
400 Kelvin po.
Times
14,000 joules over 400 Kelvin. Ay, 700 Kelvin.
over 700 Kelvin. So what is our QR?
8,000 joules, ma'am.
Positive or negative?
Positive po.
So class, for the final answer, you can express it into two. First, you can write 8,000 joules, but you will note here that it rejected. Else, you have to write QR is equal to negative 8,000 joules since heat is rejected. So either of the two will do. Clear? So you can write this or you can write this. Oops. Okay? So thank you, Mr. Saki. So letter B, QNet. WorkNet. Who wants to try? Mr. Hosen?
Ano po, ma'am? Para makuha po yung worknet ay gagamitin lang po yung formula na QA minus QR.
Very good. So, this will
Tapos
be,
ano po, ang QA po yung 14,000 joules
okay, 14,000 joules.
minus ano po, minus yung negative na 8,000 joules.
So, this will be 8,000 na lang.
Opo.
Oops. Wait lang. Wala, na-end ko yung presentation. Wait lang. Let me share again. Wait lang, guys. Okay, continued. So, this is 8,000 joules. And what is the word net?
Ang work net po ay 6,000 joules po.
Correct. So, this is 6,000 joules. Okay, last. We are going to solve for the efficiency. So this is letter C, efficiency. Mr. Batas,
Ang ginamit ko po is work net over QN po.
work net over QA, yeah, you can use this. So what is the answer? The data here. What is the work net?
Ano po, yung sagot po ni Mr. Hosan na 14,000 plus 8,000 po. All over 14,000 po. Ayun po,
Ah,
6,000 joules po pala.
6,000 joules over what is Q added? 14,000 joules. And what's your answer here?
0.42857. 14286.
14286. So let's multiply this to 100%. Efficiency in 3 decimal places is
42.857 po.
correct. Let us also try to use class the other formula, yung with TH and TL. So we can have it as TL over TH. Let us substitute. This is 1 minus what is our TL? This is 400 Kelvin over high temperature is 700 Kelvin. What's the answer here, class? What's the answer? Mr. Aguila? Correct. So, answer is also the same. So, you can opt to use any of the two. Or you can use also the TH minus TL over TH. Okay? Do you have any questions, class? For Carno? For this problem, do you have any doubt? None? Okay, so let's proceed to the last problem. Please read the problem, Mr. Zorilla.
7,500 joule of heat energy is absorbed by a heat engine from the hot reservoir at 600 Kelvin, and 6,000 joule is released into the cold reservoir at 300 Kelvin. How much work is performed by the heat engine? Calculate the efficiency of this heat engine. What is the maximum efficiency of this heat engine?
Okay, thank you. So I will give you class 15 minutes to solve this problem. So in your notebook now, then I will call someone to read the solution or to give the solution. Okay? So let's discuss the answer at 8:20 or 8 ano na 10 minutes na lang. Too much ang 15 minutes. So let's discuss the solution by 8:15. Okay? Try to solve class. May I call on Mr. Sean Michael?
Hello po, ma'am.
Hello. Morning.
Morning po.
Please start with a given.
Ma'am, ano po, QA po, 7,500 po.
Okay.
Then, TH po yung 600 Kelvin po. Then, yung 6,000 joules po ay QR. Then, ang TL po ay 300 Kelvin po.
Okay. What are the required?
Ang required po ay yung work net po, yung work po, at saka po efficiency and maximum efficiency po.
Wait lang. Okay. So let's start with the solution.
Ano po, para po makuha po yung work net po is QA minus QR po.
Solution letter A. Work net is equal to QA minus QR.
Bale po, ano po, 7,500 joules minus 6,000 joules po is equals to 1,500 joules po.
Okay, that's correct.
Ma'am, ang sabi po ang ginamit ko po ay yung ano po, pagkuha po yung sa efficiency po, yung 1 minus TL over TH po, times 100.
That is for the maximum efficiency.
Pang-max po ba yan?
Let's use the work net over QA for the efficiency here.
Sige pa. Work.
Mm-mm.
Ang sa ano po is 1,500 over 7,500 po.
Is ayun.
Is equals to 0.2 po.
Over 7,500.
7,500 po.
And this is
0.2 po. Tapos po times 100 is 20% po.
so class, sa tingin nyo, why do you think the formula that we used here is the W net over QA and not the formula including the temperature? Anyone who wants to give his or her input? Okay. So the reason why class is because we are already given with the with the uh, heat added and heat rejected in the system, meaning in real life those two parameters given already considered the losses. However, in the maximum efficiency, what we are considering here or what we put into consideration is only the temperature, the high and low temperature. And in reality, if we base the efficiency to temperature only, we are gonna get the maximum efficiency. Ulitin ko. So in the QA and QR, these values here already have the losses. Kumbaga, siguro in real life, this should be 8,000 joules, but since it has losses, it became 7,500 joules. Okay, so that's why we use W net over QA for the for the second question. And then for letter C, we are going to use the formula involving only the temperature. So this is like the letter B or the second requirement class is the actual. It is the actual efficiency. Whereas letter C, it will give us the ideal efficiency. Are we clear on that? Okay. So let us now solve for the third requirement, which is the maximum efficiency. Dito na lang sa taas.
Ang ginamit ko po ma'am sa ano po, sa pagkuha po niyan is yung 1 minus TL over TH times 100 po.
Correct. 1 minus TL over TH times 100%. So this
Um,
is
1 minus 300 over 600 times 100% po. Then ang sagot po na nakuha ko ay 50% po.
correct. So maximum efficiency natin class is 50%. Clear? Okay, so that is all for the Carnot cycle. So I asked Sir Roy Latayan if until what topic he's going to cover for the final. So he told me that his coverage will be up until Carnot cycle only. So I would limit also the coverage to Carnot cycle only, but tomorrow, if you want, I can discuss other cycles like Otto, Ericsson, but we will not include that in your finals exam, if that's okay with you. Because we are planning to have the same exam. I am planning to have the same exam with Sir Roy. No, so yan class, up until Carnot cycle yung ating final examination. So tomorrow, you may, I will not conduct yung attendance, but if you want to learn about auto and other cycles, can choose to attend. But again, I will not record the attendance. Okay? But let me know if may a-attend. Kasi baka mag-class ako tapos wala naman palang willing to learn ng ibang cycles. Okay? So, do you have any questions, class? Any questions? Yes. Mr. Gonzalvo? Napindot lang ba? Or...
Ma'am, ano pong coverage na po ng finals?
Finals. So your final exams coverage will be from the ideal gas processes up to Carnot cycle only. So Carnot cycle lang yung nadagdag from the quiz to coverage. Okay? And also everyone in this class, please accomplish the evaluation in the portal for your professor in Thermo 1. So please accomplish it already. I still see that few of you is not yet done. So please accomplish that if pwede within the day or tomorrow. Okay? Questions pa? So for those who will not be attending tomorrow's class, so I think this will be the last meeting for you for this semester. So I hope those who will not be attending tomorrow's class, I hope that you have learned something in this semester, and I'll let you know, class, if there will be some remedial activities for those who will not meet the tres na grade, the 3.00 na grade. So I will be giving a removal exam. So that will be a one-time removal only, not unlimited. So give your best if you are given a chance to take the removal exam. So those who are not uh this this those who are not in the list for removal exam and you know that your exams are too low, so I'm sorry, no, uh you still need to exert more effort in this subject, maybe next semester. Okay? So any questions pa, class? So again, I will conduct a removal exam for those who will be qualified to take the removal exam. But for those who knows that you have a too low score in your quiz, in your midterm, or you're not submitting your problem sets, do not expect that you will be given a chance to take the removal exam. Okay? Questions, class? Concerns? Wala? You don't have any last words? Charot. Joke lang. Wala na? Okay, so if wala na, class, again, thank you so much, everyone. Thank you so much for participating and for attending my class. I hope soon you'll have your ENGRs also at the front of or the start of your names, no? If you will not make it this time, huwag kayo susuko, no? Baka need pa ng more effort para sa pangarap. Okay? So, yun lang. Thanks again, everyone. And till next time. Till tomorrow for those who will attend tomorrow's class.